the problem now is that rear reaches at the end and front is over here. So actual queue is between front and rear only. By the way, if I ask you the question, in this particular instance, the what I am doing basically, what is the number of elements in the queue? Number of elements in the queue at any given point in time. What is the expression for that? Rear minus front plus 1. Okay, because rear minus front and plus 1 because both the elements, the one which is at rear as well as at front, both are valid. So rear minus front will give you the elements in between, and plus 1 I had to do just to say that both elements are being considered. Otherwise, one element is considered less. So this is basically this is an expression that I know. Now it might happen, you can see directly from the diagram that rear minus front plus 1 is not equal to the array size. Okay, it is smaller than it because these elements at the start essentially are unused. Okay, so now I am going to declare, but now my insert cannot move ahead because I will move ahead only if typically this is what I will say, if rear is less than max size or size of the queue size basically, then only I will do this. Okay, otherwise I cannot cross the size. Now don't pick me up on that size minus 1 or size, you decide basically what it should be. But the last one basically is going to be size minus 1. So if rear is equal to is less than size, which means up to size minus 1, then that is also a problem. So maybe you will say that it is size minus 1. So the condition is that there is some condition in the end basically which I need to use, and under which only the insertion should take place. Okay, the essential point is when you reach at the end, rather I should say that if you are not reach at the end, then only you do rear plus plus. Okay, and what that exact condition is we can determine. So now the thing is that we have reached to the end and I cannot insert. But the problem now is that there are a lot of elements at the start which are empty. Okay, which perhaps I could have used, but I cannot use it now. So the one solution which can come and which someone has given, a couple of people have thought through when I asked the original question itself, is that they realize that this problem is going to happen. Your queue size is smaller. So they said that this can be solved in your, where is the problem? Problem is in the delete basically. So what happened was when you started basically initially when you were over here, okay. And so they said that, the problem is that when you moved this front to the next location, like over here, okay, there is a problem because now you left this first position empty over here. So what you do is, and perhaps maybe at that time rear was not here, rear was somewhere else, perhaps rear was over here. So they said that why don't you do this? I mean this is not good, and this is like, if you take the analogy with the actual queue, if a person moves out, okay, from the head of the queue, and the window does not move. Otherwise, when I'm moving the front, it is like that the servicing guy is moving around, which is okay. But essentially, they're taking analogy that the person the line shifts essentially, right? So they say that why don't a line shift? So essentially they are saying that when you want to service this guy and this guy's service is done, do one thing, let the line shift. And they are saying that let the line shift mean let everyone move one position to the left, starting from this position, which means that this rear will move now over here, somewhere over here. So essentially the line shifts to the left. Okay, then in that case, this problem does not arise. Okay, so the point over here is that in that case, what is going to happen is because line is going to shift, so all the initial elements are going to be utilized. So the front is always at location 0 and rear is basically at where the rear is. So if at all rear reaches at the end, it is really the case that the array is completely full, and not that array is not full, but still I am declaring that array is full. Okay, so this is another solution. So what is the solution? Solution is that every time you do the delete and you have to move the things to your left. Have you noticed one thing? The problem happened in insert, but the solution is given by the delete. Okay, so these two, this insert and delete, these two functionalities have to be thought together. They cannot be thought separate. So the problem of insert is getting solved by solution in delete, where I'm saying that when I do the delete, I know that front is going to shift. Rather than shifting the front, I will keep the front as it is, and I will move all the elements from right to the left by one position. Okay, that in that case, front does not move. So in that case, my delete function will be a little bit different. It is not like front less than equal to rear and service element at different. It is always I will always service the element at 0, at location 0, and then I will move all the elements to the left. But I don't like the solution. I don't like the solution because it is if you see what I was earlier doing, if you see these solutions, I'm just doing rear plus plus and insert the element at the rear. I'm doing service element at the front and front plus plus. So these are order of one operations. These are constant time operations. Okay. Whereas when you want to move all the elements to one position to the left, okay, from overall perspective, normally when we are standing in the queue, we do the people who are servicing us don't get bothered. They say it is your problem. You have to just move few steps ahead. But from system perspective now, from the implementation perspective, whatever is the number of elements, basically the deletion is going to take that much amount of time. So deletion is not constant time now. Okay, that is the point. So deletion is not constant time. Insertion is constant time. So there is a hit or penalty I have to take in the deletion. Now the next condition that I don't want that. So I want my deletion also to be equal to constant time operation, which means I don't want to move elements from one position to the left. That is what I am saying. So which also means that basically my front can keep on moving, but at the same time as the front moves, which is okay, front moves and rear is over here. But when rear reaches at the end, at that point, essentially what I want to do is I want to somehow utilize the elements at the start. Okay, and I don't want them, so unless those are occupied, I will not declare that the queue is full. So question is, how do I do that, or what is the visualization that I can have? So yeah, so there is Omkar is saying something else, that rather than every time doing it, why don't you do this basically only when rear reaches at the end, then you do that. I agree, but then remember that even in that case, it is only the first time you are going to avoid the problem. But once rear reaches close to the end and there are a lot of insertions taking place, you will more often reach to that condition. Okay, but then again you will claim that okay, but then in that case again the queue needs to be full. So I agree that this is a much better solution. What Omkar is saying, that what you do is when everything, when rear reaches at the end, you decide at that point, and only at that point only all the things to be shifted to completely to the left. So front goes to the location 0 and front plus 1 go to location 1, etc. Everything shifted to the left. Very good solution. I mean, and that definitely works out better than the previous one. At least I can claim that I'm not shifting every time. Okay, I'm shifting only when it is desired, only when this rear reaches at the end, which is perhaps will happen once in a while. Finding complexity of that is little bit not very easy, let me tell you. That depends on a lot of other factors. We'll not get into that. But agreed. But then can there be something else basically? There is still some shifting which is going on over there. I want to avoid the shifting completely. So what do I do? Great. So I think people are getting the idea. Vishakha got some idea. Omkar got some idea. Akanksha got an idea. Gaurav got an idea. So they said that if this is the situation that you are in, why don't you utilize these elements? But how do you utilize these elements? So this rear has to go to 0. Okay, so where rear is at the max size minus 1, it has to go to 0 and then it has to come back over here. But now, as I think someone has pointed out, then your condition, some other conditions might change. We'll see what conditions will get changed. Okay, so the before that, if I don't take that, that is called a circular array. Okay, circular queue. If I don't take that, if I have this normal situation, I said the number of elements in the queue is this, and you have to worry about, I mean, in this case and in all the cases, you have to worry about, I have not said that what is the condition for queue full. So what is the condition for queue full? So number of elements in the queue. So condition, I will say that conditions in normal situation. Okay, so I have number of elements in the queue. For that it is rear minus front plus 1. What is the condition for queue being full? So condition for queue being full, it is not allowing me to do this. So, okay, so I think I have to change the type. Okay. And suppose I do this. No, okay, it is not allowing me. Okay. Okay, let's forget about it. So if it is queue being full, what is the condition for queue being full? Let's say normal situation. What is condition for queue being full? In this case, it was very easy. The condition for queue being full was rear going to the end. Rear is equal to size minus 1. Okay. And what is the condition? Another interesting condition that I might want to think about. is what is the condition, and you think about it, I don't answer that question right now, is that what is the condition for Q being empty? Okay, it's not very easy to guess. Okay, you have to little bit think through this. So what is the condition for Q being empty? In the normal situation, when this front is at the start, rear is over here, I don't do this moving around rear, coming back over here. So in normal situation, what is the condition for the Q being empty? Think about it. Okay. So remember that what will happen when front and rear at the same position. Suppose I say that front and rear at the same position. It is the condition for front equal to rear. What is the meaning of front equal to rear? Meaning of front equal to rear is that there is a single element, because this element, it means that this front and rear is over here. It means that both front and rear at the same position. It means that that is the element which will be serviced. So that element is still there. And if you want to add new element, you can just move around rear. So front equal to rear is a condition for single element. Okay, so let me say that I asked you the condition for Q being empty. So I will say that single element condition is front equal to rear. Okay, so does this give you any idea now? If this is the condition for single element, what is the condition for Q being empty? Okay, so think about it. Okay, rear plus 1 equal to front. Okay, yeah. So basically the condition for Q being empty, imagine that front equal to rear is the condition for single element. Then in that case, imagine that this rear is actually, instead of it, rear is over here itself. And now I want to delete the number. And if I want to delete the number, then this front will, what did I say in delete? That this front has to move to front plus. So front will move to one element next. So rear will be behind and front will be ahead. Okay. And so the condition for Q being empty over here in this particular case is that rear is behind and rear plus 1 is equal to front. Remember this condition. Okay, we'll come back to this condition later on. Okay. So let's say that these are the things. So this is what we have noticed. So single condition, element condition is front equal to rear, and Q being empty condition we just figured out is that rear plus 1 equal to front in the situation, in which case so essentially front will cross over the rear. That's what will happen, and then that is the condition of Q being empty. This is very, very important condition, let me tell you. Okay, so let me make it bold and underline. Okay, there is a reason why this is important condition. But now to solve our problem, what we are doing is that we are saying that we want to utilize the elements at the start also. So we can basically, I'm saying that after this rear reaches over here, if I want to add a new element, this rear has to go in over here like this. Okay. So if you notice that in the insert, what I am doing basically is that rear is less than size minus 1 is no longer the condition. It is no longer the condition for the Q being full. So what is this condition is what I need to worry about. So what I will do, I cannot do rear plus plus. I will do if, or rather I will say that if rear is less than size minus 1, then in that case I will do rear plus plus. Okay. In the else part, if it is if else, if rather I will say that else if rear is equal to size minus 1, then I will have to set my rear equal to 0. Okay, and then I will insert the element which is insert the element at the rear. Okay. So when rear is less than size minus 1, I am doing a rear plus plus without any problem because rear is going to the next position. But if rear becomes equal to size minus 1, I am setting my rear to be equal to 0. Now let me ask you the question. Can I combine these two conditions together? I don't like this, this if-else statement over here. Can I somehow combine these two things in one single expression? Is that possible? Yeah, so I think Sarthak got the idea that it is a modulo operation, because if you see what rear is doing is that what values that rear is taking. The values that rear is taking are basically it is moving from 0, 1 up to size minus 1, and when it reaches to size minus 1, it will again come back to 0, 1, like that. So essentially this is nothing but the modulo operation. Okay, so what I can do over here, rather than doing this, rather than saying this actually rare plus was nothing but rare equal to rare plus 1 earlier. Okay, what I will do is forget about this condition. I will say forget about this. What I can do is both things can be achieved together if I do rare equal to rare plus 1 modulo, which is percent, and what is that? Let's say size, let's say, is the size of the q, or let me call it as q size. Okay, so what I will do is I will say that rare equal to rare plus 1% q size is the thing, and wherever rare goes I have to do this. But remember, I have to still check the condition that whether q is full. Q is not full, then only I need to do this. So I need to figure out the condition for Q being not full. Okay, or rather I have to check the condition. I have to know the condition where the Q is full. Okay, so I have to arrive at that condition. So now the rare is sorted out, and now imagine that this rare basically still moves, and rare reaches, let's say, over here. Rare reaches over here, let's say. Okay, and front is over here. So it is still one element short of Q being full. Do you realize that? That it is one element short of Q being full, because there is still this gap which is over here. So what I can do is I can put one more element, and I will say that this is the condition for now the Q has become full. So what is the condition for Q has become full now? It is not equal to rare equal to size minus 1, but it is rather, it is basically saying that rare plus 1 is equal to front. But then what is the problem now? What is the problem now? What is the problem now? Yeah. So the also when front equal to 0 and rear equal to size 1, we'll consider that condition. Okay, that is a normal condition. But what is the problem now? Rear plus 1 equal to front. Yes. So I think you have to pay attention to what is in front of your screen. That we said that for Q being empty, the condition is exactly same. Okay, for Q being empty, the condition is exactly same. So now the problem is that no, not this one. This I wanted to underline. So now the problem is that for both Q equal to full and Q being empty, I have exactly the same condition. If I want to just consider that front equal to 0 and rear equal to size minus 1, can I make a small change to this condition, and without writing an expression I can do that? So first we understand the problem. Problem is that condition for Q being full and Q being empty is exactly same, which is rare plus 1 equal to front. Okay. Now I am saying that, as I think Onkar or someone pointed out, Onkar pointed out that front equal to 0 and rear equal to size minus 1 also is the condition, and he says it does not work. Okay, in this case, I agreed. So what is the small change I can do? I can do a modulo operation. So I can say that rare plus 1% Q size is equal to front. If I do this, then it takes care of both the cases, that front is 0 and rear equal to size minus 1 is Q full, and the other case where basically front is just one position earlier than rear is just one position earlier than front, or front is ahead of rear by one position. But now my problem is that and does this work, by the way? Number of elements in the queue in that case, rear minus front plus 1? No. Now what is the number of elements in the queue? Now that I have done the circular thing, so this works when rear is greater than front. What if when rear is less than front? What is the number of elements? What is the number of elements when rear is less than front? You understand rear is less than front, right? That is the condition where rear has wrapped around and rear has come back, like this over here. Let's say that if this is confusing, let's put it this over here. Now you want to find out number of elements in the array. Don't answer that it is size minus 1 just because you can see this. Normally, I can put it anywhere else. Is it front plus rear? Are you sure? So how many elements are there? From 0 to rear. So if I have 0 to rear number of elements, which is rear plus 1. Okay. Okay. This many. And how many elements from front to size minus 1? Plus size minus 1 minus front plus 1. Okay. Solve this expression. Plus 1 minus 1 cancelled out. This plus 1 remains. So I will remove this plus 1 and I will remove this minus 1. So what I get is rear plus size minus front plus 1. I will readjust this and I will say that it is actually the same expression. Minus 1 front plus 1 plus size. So if you see these two expression, it is rear minus front plus 1. Here it is rear minus front plus 1 plus size. Okay. When that expression became negative, basically it is I add plus size to that and then I get the element. So this is the number. This is how I calculate the number of elements in the queue. This is how I can calculate number of elements in the queue by saying that rear minus front plus 1 plus size. When rear is less than front and rear is greater than front, it is rear minus front plus 1. Okay. Fine. So what was the question that I was asking? That so this is the queue. This is the condition when which tells me number of elements in the queue. Queue being full, we decided that we realized that queue being full and queue being empty is exactly the same situation. Now, the one thing which and you will see why that is the situation, why that is the case, because rear plus 1 equal to front, basically, there is another way in which, okay, so there is another way in which now things can happen. Now, let's say that rear has come in over here, okay, and the queue has become full. But now what has happened is this front has started moving around, and this front actually moved up to the end. So let me move this front over here. Okay. And now it services this element. If it services the last element, where should front go now? Front also need to move at the 0th position because that is where the next element is. So you imagine that what I'm considering this as a someone pointed out as a circular array. Okay, I'm considering, so if I need to draw, I will say that what I'm doing over here is that I'm considering this array being a circular array. Okay, and basically it is just that the size minus 1 is just next to 0. So essentially this is what I will draw, and I will say that you imagine that this is size minus 1 and size minus 1, this last location is size minus 1, which is at 11 o'clock, and this whatever is at 1 o'clock essentially is position 1, is location 0. So you are just wrapping around the things. Okay, this is how you have to imagine. Now in this particular situation, the front also has to wrap around, right? I mean, after it serves the last element, it has to come in the front. Okay, this front pointer has to come in the beginning and it has to start servicing from here. Okay, so if it has to service from here at the starting position at the front, basically, then in that case, your front needs to become front plus 1. Okay, which means that in the insert operation, in the delete operation, it is not front plus plus. Now check the condition that queue is empty. Okay, that's why I said that is front is less than equal to rear. Is that the condition now for the queue being empty? What is the condition for queue being empty? Unfortunately, my condition happened to be exactly same as queue being full. So I will just write over here queue is, check the condition, queue is not empty. If queue is not empty, service the element at the front, and then instead of doing front plus plus, what you have to do is you have to do front is equal to front plus 1% queue size. Okay. So we will say that this front equal to front plus 1% queue size is the condition for queue being, so rather is the condition for front to be moved ahead 1 by 1 position. So it means that if front reaches to the end, it also moves ahead to the 0th location. Okay, so now another situation can happen that, and this is a kind of, we have kind of seen it, that front moving over here and like this is like something which we had already seen. I mean, this is where we started actually, right? And then again the things will keep on moving around. I mean, again, the rear will move ahead, maybe front can also move ahead, and this will just keep on happening. This will just keep on running around. Unless basically if queue is full, you cannot do anything. If the queue is empty, if queue is full, you cannot insert. If queue is empty, you cannot delete. That is the extra thing. Unfortunately, I had to resolve the situation that my queue full and queue empty conditions are exactly same. Okay, and here also I had to do this rear plus 1% queue size percent queue size equal to front. Okay. And why this is required is, I mean, I can write this without any side effect, but there is a reason I'm writing this. So at least it shows that queue full and queue empty conditions are exactly same. Okay. Otherwise, if you claim that the queue being empty condition is always the case that air plus 1% queue size equal to front, I agree. But let me write this condition. Okay. So yeah. This is mainly required if you think this condition is this percent queue size is still required when actually what has happened is that your rear was at the end, at the last location. Okay, and your front came in. Okay, and your front basically at the start, let's say, doesn't matter, rear was over here, and your front basically started coming in. It reaches to this last position, which means that it is a single element now, and then you deleted that also, and then front moved ahead over here like this. Now again, in this case, the queue has become empty. Have you realized that? Because initially this was this, front moved up to the rear, only single element, that also got deleted, and front again came over here. Now this is a condition again for queue being empty, and I know that it is being empty because I just deleted the element, right? So I know it is empty. So again, this condition that rear plus 1 equal to front, but I cannot directly say that. So rear plus 1% queue size equal to front itself becomes the condition for queue being empty. Okay, so the problem is the same, which is I have the duplicate or ambiguous condition for queue being full and queue being empty. Okay, this I have to resolve. And this is the whole problem with this circular array or circular array. Okay, first decision is we made the decision to get this circular queue thing done. And moment we do that, this is called a circular array or circular queue. Both things are fine to say. Ideally speaking, one should say it is circular array actually, not circular queue. But people tend to say that it is circular queue, which is okay. And but the problem is that both conditions are exactly the same. Okay. Now, when do I know that the queue has become full, or when do I know that queue has become empty? Let's just point it out. I know that queue has become empty, just like I showed you right now, is that front cross the rear. And that happens in the deletion. When front cross the rear in deletion, I know that queue has become empty. Okay. And when rear cross the front, okay, or the rear reach to the position which is just earlier than the front, that is when I know that in insert I just added one element, and now my rear plus 1 equal to front means that queue is full. Okay, remember this. If you don't want, basically we need to write down this condition that in insert I know that queue has become full when rear plus 1% queue size is equal to front. Okay. And similarly in delete, I know that queue has become empty. In delete, I know when queue has become empty when this, the mechanism is different. In insert, it is the rear which goes close to the front, whereas in delete, it is the front which crosses the rear. So this we need to remember. Now, to all those people who are trying to put again and again the messages that why I'm not, one should consider count, one should consider n, one should consider number of elements, and I'm not still paying attention to that, and they are wondering why I'm not doing that, right? I mean, so many messages I see that that you put one element, you do count, you do this, you do that, etc. So, do you think that I'm not aware of that? Do you think that this is not the solution that is crossing my mind? That is not the point. The point is I want you to appreciate what is happening in this queue mechanism. If you take that solution and you solve, you will never realize that what all these different conditions and ambiguities are coming in. Okay, and later on we will see that I will make sure that, or rather I will say that I will not going to take this count variable and then solve the problem. Let me put the question right now. If I say that you are not allowed to take the variable which counts number of elements in the queue, what will you do? And to know that, you have to understand all this discussion that I am doing right now. Remember, this discussion that I am doing right now is not the solution. Have you realized that I am not discussing the solution with you? I am discussing the properties of the problem. I am still discussing the problem. I am still discussing that moment I decided to go for circular queue, what all things are happening. I am trying to understand the problem. I'm not giving the solution. I'm not asking for the solution right now. I'm saying that these are the problems that I'm facing, and these are the observations I'm making. And I'm saying, I said multiple times in the last this thing also, that we have to make observations. Okay. So I'm making all these observations for you. Otherwise, I need not make these observations. I can just directly give the solution, end of story, and then come back over here. But right now, I'm saying that moment has decided to go for circular queue, what are the implications of that? What are the implications coming out of moment because of that one single decision? And now I am tying up all the things together. I am saying number of elements. This is the how I need to count. Q being full and Q being empty is exactly the same condition. And then what is also happening is that, but still I know that when Q is full and Q is empty, in some way I know when this condition happens in insert, where basically what happens is rear reaches close to front, whereas in case of delete, what happens is front crosses the rear. Okay, so these are all the observations I am making. Okay, these are not solutions I am giving. I am not asking any question over here. So just focus on the observations. So here front crosses the rear. Typically, we are so anxious to give the solution that we miss out on the observations. Okay, remember that observations are very important. So we are trying to understand as much as possible from this diagram. And now it's 11 o'clock already. Let me put just the last line. Now that I want to solve this problem of ambiguity, the simplest solution I could have given is by starting count equal to 0, which is count is the number of elements in the queue. Every time I do insert, I do count plus plus, and every time I do delete, I do count minus minus. And now moment I do that, it becomes very easy for me to, the queue being full is basically count is equal to size, queue size, and queue being empty is basically becomes count equal to 0. Okay. So this is, I should say, count not equal to 0 and the count not equal to queue size. Okay. So these are the conditions. This is the condition for Q not being full. This is the condition for Q not being empty, under which I can do this now. Count plus plus for this, count minus minus for this, and that's what will solve the problem. But at the same time, don't forget these observations. These are the observations. This we know extra thing for the given problem. So with this, I stop and we'll continue from this point onwards. You can try writing some implementation for Q now. You know the idea. Otherwise, we'll do that in the next lecture. Okay. Thank you.